We now continue with the light energy, and we are now on spherical mirrors. So spherical mirrors are basically the different kinds of mirror which you normally would have seen in a laughing mirror. You know, when you stand in front of us, you look a bit fat or you look very thin and tall. So all those the things what is happening is because of the spherical mirrors. So spherical mirrors, the general, the when you are saying talking about a spherical mirror. So what is a spherical sphere? Sphere is nothing but a ball. So if I take a ball like this, and suppose this complete ball is made up of mirror, okay, it's made up of glass, okay, not mirror but glass. And so to make it a mirror, what I need to do is that I need to coat one of the area with silver coating so that it becomes a reflecting surface. So normally if you see the mirror is just a glass, और यहाँ पीछे के साइड पे उन लोग ने silvering किया होता है so that यहाँ से it is reflecting. Okay, so here if I am going to, so there are two options. I can coat the silver like this on outside so that this part becomes the reflecting surface. It's reflecting, not refracting. Or else I can coat it from inside over here like this so that this part over here is the reflecting surface. So accordingly, I get two kinds of mirrors with a sphere. This one, which is a cave-like thing, it's called as concave. And the one which is outer side being the reflecting one is called as convex. Okay, so there are the two kinds of spherical mirrors. The concave mirror, which has got the outer side of the sphere as the silver surface and the inner side forming the cave. You know, cave, ये cave जैसा है, तो ये वाला अगर मैं ऐसे देख सकता हूँ, अपना मुंह यहाँ पे ऐसे इसमें देख सकता हूँ, then this is a concave mirror. And if I'm putting it like this and I can see my face here, then it's a convex mirror. So convex mirror is coated from inside and I can see the outside will be the reflecting surface. If inside is the reflecting surface and outside is the coating, then it is the concave mirror. Okay, so there are the two kinds of mirror. So spherical mirrors are made by silvering the part AB of the hollow glass sphere as shown in the figure 5.17. The surface on which silvering is done is called as the silvered surface, and the reflection of light takes place from the other surface, which is called as the reflecting surface. So over here, this over here is the silvered surface and this is the reflecting surface. Right, same way over here is the reflecting one and here is the silvered one. Okay, this is the silvered surface, this is the reflecting surface. This is a reflecting surface. Got it? So kinds of spherical mirrors. There are two kinds of spherical mirrors, the concave mirror and the convex mirror. Okay, there are two kinds of mirror, that is concave mirror and the convex mirror. Concave mirror is made by silvering on the outer surface of the hollow sphere such that the reflection takes place from the inside hollow or concave surface as shown in the figure. So when the outside part is silvered and the inner part becomes the reflecting surface, it's called as a concave mirror. A convex mirror is made by silvering the inner surface such that the reflection takes place from the outer surface, convex or the bulge surface as shown in the figure 5.18b. So that's why this is a concave mirror and this is a convex mirror. Inside reflecting, concave; outside reflecting, convex. Now when we talk about the spherical mirrors, there are certain very important terms which are going to be used in case of concave mirrors or convex mirrors. So this, whatever are there, let's see one by one those things. So what we are going to do is that we are going to take these terms for both the convex and the concave mirrors simultaneously. So what happens is, this is a sphere and to the sphere I am reflecting it inside. So the coating is done on the outside. So accordingly, this is a concave mirror. Now this is the center of the circle. This is the radius, and this is the center of this reflecting surface called as the pole. This is the center C. Okay. Similarly, if I take this as the sphere and I have reflected the surface over here like this, so the inside is coated, then this is the center C. Again, this is the P and this is the radius. Okay. Now, the straight line which is going to be the diameter over here is called as the principal axis. Okay, this is the principal axis. So let's understand the different terms what we are going to use in case of spherical mirrors. First one is the pole. So this thing is the pole. The geometrical center. So if this is a mirror, ये mirror का center, geometrical center. The geometrical center of this particular disc is the pole. So the geometrical center of the spherical surface of the mirror is called the pole of the mirror. It is midpoint of the aperture AB of the mirror. It is represented by the symbol P. So the center of this AB mirror, P is the center of AB. Here also P is the center of AB. So pole is the geometrical center of the aperture. Aperture means the complete reflecting surface of the spherical mirror. So complete reflecting surface of space. Suppose ये अगर spherical mirror होता तो इसका center would have been the pole. Second is center of curvature. Now the center, ये circle बनाने के लिए जो हम लोग ने center use किया, that is the center of curvature. Okay. So center of curvature. The center of the curvature of the mirror is the center of the sphere of which the mirror is a part. Okay, the center of the sphere of which the mirror is a part is called as the center of curvature. It is represented by the symbol C. Note the normal at any point on the minor on the mirror passes through the center of curvature. In other words, a line joining the center of the curvature to any point on the mirror is normal on the mirror at that point. Now, not is a normal. Normal is a perpendicular drawn from the center, perpendicular drawn from the surface of the mirror. So, if I am drawing any line which is passing through C like this, so this line which I have drawn over here becomes the normal. Any line. From here, if it is passing and it is going over here, तो ये point पे ये वाला जो है वो उसका normal होगा. This is the normal. Okay. So normal will be the one which is going to pass through C. Now why is that important? Is because we very well know that if a ray of light is passing through the normal, it is on the normal, then it is reflecting back on the normal only. If you remember in refraction also we did this thing, कि ये line था और ray of light fell like this, which was perpendicular, so it returned, it just went undeviated. Similarly, in case of mirrors, this was just going to reflect back on the same line. So that's why it's very important to know that what is the normal in case of spherical mirror. The line which is passing through C at the points of incidence is called as the normal. So this over here line is a normal, this line is a normal, okay, and here whenever the ray of light, an incident ray is passing through the center of curvature, that means the reflected line will also be passing through C. Okay, we'll learn this thing a bit in detail also later on. So very important point. Note the normal at any point on the mirror passes through the center of curvature. In other words, a line joining the center of the curvature to any point on the mirror is normal to the mirror at that point. Third thing is the radius. You know what is the radius? Circle draw करने के लिए जो measurement लगता है, that is the radius. So radius. The radius of curvature of the mirror is the radius of the sphere of which the mirror is a part. So the radius of the sphere of this which the mirror is a part is called as the radius of curvature. Thus, it is distance of the center of the curvature from any point of the surface of the mirror, that is figure 5.19. This is represented by symbol R. So we see over here that this is the radius R. This is the radius R over here. This distance, that is from center to any point on the so even this part, this line over here, this much distance is the radius. This is also the radius. Yes. So radius is the distance between any point on the mirror to the center of curvature. Fourth is principal axis. It is a straight line joining the pole of the mirror to its center of curvature. In figure 5.19, the line PC represents the principal axis. It may extend to either side of the pole. So that means the line joining the pole to the center of curvature, that line, okay, which can even extend further or go here also, that particular line is the principal axis. So principal axis is the line which is joining the P, that is the pole, to the center of curvature. Pole to center of curvature, the line connect karta hai, that is the principal axis. The next one we see is the focus as a focal length. Now to understand the focus and focal length, we need to understand some concept about the spherical mirror. Now it is seen that when I take a spherical mirror, so suppose I take the spherical mirror, this mirror is a concave mirror. When rays of light are going to be falling on this like this, it will be seen that the ray of light, क्योंकि ऐसा है तो इधर आने के बाद में it is going to go inwards. So this ray of light is going to converge. So this over here is again going to converge. So all these lines which are going to be the incident ray, which are parallel to the principal axis, they, after reflection from this particular mirror, they are going to converge at a point. All these lines which are parallel to the principal axis, all these incident rays which are parallel to the principal axis, after the reflection, after they are reflecting from this mirror, they are going to converge. That means combine or meet. Okay, they are going to meet at a point. This point where they meet is nothing but the focus, the focal focus over here, F. Okay, and the distance between the pole and the focus over here, this distance is nothing but the focal length. In case of any spherical mirror, it will be seen that radius is equal to twice the focal length, or focal length is equal to half of the radius. Now if I take the same thing in case of a convex mirror, what is going to happen over here is that if this is the mirror, the rays of light are going to come here like this. Now, because they are like this, they are going to reflect in the diverging form. See here, this is converging. But here, it is diverging. Okay, they are going to diverge. Diverge means go away from each other. So here they are going to go away like this. This is going to go like this. This is going to go like this. This will go straight because it's just straight line. This is going to go like this, and this is going to go like this. If I am going to produce them backwards, it will be seen that they all will be meeting at the same point behind the mirror. Okay, it will seem as if all these rays are originating from this particular point, and then this point is the focus. Got it? So in case of a convex mirror, so this is of course concave and this is convex. So in case of a concave mirror, we have got a real focus, whereas in case of a convex mirror, we have got a virtual focus, because this is not actually, the light rays are not actually meeting at that point, but we feel as if it is coming from this point. Whereas over here, they are actually meeting at a point. So that's why this is the real focus, whereas this is the virtual focus. So let's see what is given over here. In class 7, you have learned about reflection of light on a plane mirror. When a ray of light is reflected from a plane mirror, it obeys the following two laws of reflection. Angle of incidence is equal to angle of reflection. An incident ray, reflected ray and the normal all lie in the same plane. The above law of reflection of light holds true for the spherical mirrors as well. Focus. Figure 5.20 shows the rays of light falling on a spherical mirror parallel to its principal axis. So this is the one which is parallel to principal axis, over here like this. Okay. These rays are reflected by the mirror obeying the laws of reflection, that is angle of incidence equal to angle of reflection. The normal at the point of incidence is obtained by joining the point of center of curvature. So if I want to draw the normal, you know that this is this like this. So the normal over here will be like this. So you can see that this angle is I and this angle is R, and angle I is equal to angle R. Similarly, the normal over here will be like this. So again the same thing, this is I and this is R. Same thing happens over here. This is going to be like this and this is going to be like this. So these are all normal. All the green lines what I am showing you over here are the normal, and you will find that these green lines are dividing this with the bisector. So this is angle I and this is angle R, angle I and angle R. That is as per the law of reflection, that angle of incidence is equal to angle of reflection. So hence you find that all of them are following the law of reflection of light, and accordingly they are meeting or converging at a point F, which is nothing but the focus. So the reflected rays are not parallel to each other, but they are converging towards a point in a concave mirror while diverging from a point in a convex mirror. In case of concave mirror, the reflected ray meet at point F on the principal axis. This point is called as the focus of the concave mirror. Okay, so we can say that the reflected rays which are parallel to the principal axis, when they meet at a point on the principal axis at F, it is called as the focus or the focus of a concave mirror. In case of convex mirror, the reflected rays do not meet at any point, but they appear to come from a point F on the principal axis behind the mirror. This point, so this is behind the mirror where they are coming from point. Here again we can draw the normal. So if I have got this line, this is the center. So from here if I draw the normal, it will be like this. So this will be I and this will be R. Same thing happens over here too. This is normal. Okay. ये normal से pass हो रहा था इसलिए वो reflect back in the same line. Here again it will be the same thing. It is going to be like this, and here also it is going to be like this. So this is angle of incidence equal to angle of reflection. Angle of incidence equal to angle of reflection. So all these cases you will find that they are going to meet at point F, or seem to meet at a point F behind the mirror. So in case of convex mirrors, the reflected ray do not meet at a point, but they appear to come from a point F on the principal axis behind the mirror. This point is called as the focus of convex mirror. The focus of concave mirror is a point on the principal axis at which the light ray incident parallel to the principal axis meet or converge after reflection from a mirror. So this is the exact definition of the focus of a concave mirror. So the focus will have two definitions, one for a concave mirror, another for a convex mirror. So for a concave mirror it will be the focus of a concave mirror is a point on the principal axis at which the light rays incident parallel to the principal axis meet or converge after reflection from the mirror. The focus of a concave mirror, the convex mirror, is the point on the principal axis at which the light rays incident parallel to the principal axis appear to meet after reflection from the mirror. The focus is represented by the letter F. Note the focus of concave mirror is real while the focus of convex mirror is virtual. The distance of the focus from the pole of the mirror is called as the focal length. So the distance between the pole P and the focus is the focal length. This is the focal length. I showed already this one. Okay, so this is the focal length. The distance of the focus from the pole of the mirror is called as the focal length of the mirror. The focal length of the mirror is marked by distance PF. In figure 5.2, focal length F is equal to PF. It can be proved geometrically that focal length is equal to half of the radius of curvature. So this is the thing, that focal length is half of the radius over here. The approximate focal length of a concave mirror can be determined by following simple activity. So what you're doing is, just take a mirror, light मारो, अगर वो point mirror से एक point पे वो converge होगा, एक point आएगा, so that is nothing but the focal point, focus. So take a concave mirror and hold it such that it faces the sun. Now place the piece of paper in front of and adjust its distance from the mirror such that at a position a very small image of the sun is seen on the paper. You will notice that the paper chars at this point. This point is the focus of the concave mirror. Now the charring of the paper may or may not happen. It depends upon what is the sun, कितना heat है वगैरह वगैरह. So, but yes, be careful because अगर हाथ पे अगर लिया तो हो सकता है कि हाथ पे चटका लगे. So be careful. Measure of the distance f of this point of the mirror with a meter rule. This distance f gives the approximate focal length of the concave mirror. So this was about the different terms which we are having in case of the spherical mirrors. Now we will see that how are the images, or we can say the ray diagram, are to be drawn for the spherical mirror. So this is a very, very important part of this thing, that you need to draw the ray diagrams which are required for the spherical mirrors. Now what do you mean by ray diagram is, we are going to place objects, so we are going to draw it in such a way that we are going to take the object to be very far off, and then we'll bring it nearer and nearer to the mirror and see that what is the changes, or what is the way the image which is obtained by this particular mirror is changing. So that is what you are going to see in the ray diagrams for spherical mirrors. So we are going to follow three very important rules for that thing. So we'll understand the rules first, and then we'll start with the ray diagrams for spherical mirrors. I think we can start it in the next video. No, or we'll say I'll do one thing. I'll just make you understand the different rules for this, and then in the next video we'll start with the actual ray diagrams of the concave and convex mirrors. Okay, so first thing is we are going to have three rays. Okay, we are going to have three rays. So the object is kept in front of the reflecting surface on its left side. So first rule what you are going to follow is that the object will always be on the left side of the mirror. So that is what you are going to take. The object is kept in front of the reflecting surface. So if I am going to draw a concave mirror, okay, so if it is a concave mirror, then definitely I cannot draw it this way. I have to draw it in the form that to the left होना चाहिए. ये मेरा right में हो जाएगा. Or you can say, you can ठीक है, तुम लोग के लिए वो left right ही हो जाएगा, so it doesn't matter. So I'm going to draw it this way. So if I'm standing here like this is the mirror. To the left will be the object. So the object will always be placed. This is an object, that is AB is the object, which is going to be placed in front of the mirror to the left of the mirror. Secondly, The object is always kept on the principal axis such that it is perpendicular to the principal axis and its foot touches the principal axis. So the next thing is that the object whatever I place, it will always be perpendicular. It will always be straight and it will be perpendicular to the principal axis and touching the principal axis. Okay, that is the second rule. The third is, for constructing a ray diagram, take at least 2 rays of convenience whose path can be traced after reflection. So what you are going to do is that we are going to pass at least 2 rays from A. Okay, like one going straight like this, one passing like this, or maybe one passing like this. ऐसा कुछ भी ऐसे करके 3 rays we are going to take and they are going to be reflected back, and 2 rays, sorry, we are going to take at least 2 rays out of the 3 which is possible. We are going to take at least 2 rays to identify that where exactly will be the image of this particular point. So the point of intersection of the 2 rays after reflection will be the point where the image is going to be formed. Okay, the image will be formed at the point of intersection of the 2 reflected rays. Right? To construct the image of the object due to reflection by spherical mirrors, any 2 of the following 3 rays can be drawn according to our convenience. So there are going to be 3 rays which we can take. So according to that, whatever is the convenient thing, whether to take the first one, second one, third one, we are going to take any 2 rays out of that and find out that what is going to happen to these 3 rays. So if I take this thing, it will be seen that there are 3 possibilities. Now, you have got this is the pole, this is the focus, and this is the center of curvature. So there are 3 things. First point, second point, and this is the principal axis. So the first condition is that if the incident ray is passing through C. If the incident ray passes through C, that means if a ray of light is passing through C like this, now we know that C is the center of curvature and any line which is passing through C is also the normal to the mirror, और normal में अगर रहेगा तो क्या होता है? Angle of incidence will be 0, so angle of refraction will also be 0. So accordingly, angle of incidence is 0. Why it is 0? Because it is like this. ये ray है, ये normal है. Incident ray भी इधर ही है. So what is the angle between this line and this line? Nothing. It's the same line. So it's 0. So what will be the, if angle I is equals to 0, angle R will also be 0. Obviously, because as per the law of reflection, angle of incidence is equal to angle of reflection. So accordingly, you will find that if the incident ray is passing through C, the reflected ray also passes through C. So you find that the reflected ray will also pass through C. So that's the first kind of the ray diagram ka first point. A ray passing through center of curvature is reflected along its own path. Okay, so if you have got a ray which is passing through the center of curvature, it is going to return back with the same particular point C. So that's the first thing. So a line joining the center of curvature to any point on the surface of the line is always normal to it. Thus a ray passing through the center of curvature is incident normally on the spherical mirror. If angle of incidence is 0, therefore angle of reflection is also 0. It means that ray gets reflected back along its own path. So this is the explanation towards this particular thing. Same thing happens even in case of the convex mirror. So in case of convex mirror also, so this is C. So the ray of light is such that it is passing through C, right? So if it coming from here, will reflect back in the same direction. Okay. Now you see the next point. A ray parallel to principal axis. So if I got a ray of light which is parallel to principal axis, if I got some ray of light which is parallel to principal axis, this we had done for the focus point कि अगर parallel principal axis है तो वो कहाँ से जाएगा? Focus से pass होगा. So that's the important thing. So over here also, if it is parallel to principal axis, it is going to pass through focus. Okay. So this is the second law. The second rule or the second thing what we are going to learn about the thing is parallel to principal axis. If the incident ray is parallel to principal axis, the reflected ray will pass through focus F. So in ray of incident parallel to the principal axis, after reflection passes through the focus in case of concave or appears to come from the focus in case of convex mirror. Now we see the last one, and that is a ray passing through focus. So if the ray of light is passing through the focus, so if it is passing through the focus, it will become parallel to principal axis. Okay, if it is passing through focus, yani if it is like this, on reflection becomes parallel to principal axis. So the third point is passing through focus, it will become parallel to principal axis. So these are the very important three ray diagrams what we are rays which are going to use for the ray diagram part. First one, the ray passing to center will return back in the same path through C. The ray parallel to principal axis will pass through focus after reflection. A ray which is passing through F before reflection, after reflection it becomes parallel to the principal axis. So these are the things. So ray passing through the focus in case of a concave mirror or appearing to pass through focus in case of convex mirror gets reflected parallel to the principal axis. To construct the image formed by the mirror, we take at least two rays incident on the mirror from a given point of object. So what we are going to do is that to make any ray diagram, we are going to take at least two rays. We are going to take at least two rays from a given point and let it pass, let this one and this one pass through that particular point and see after reflection what happens to that particular 2 points, and the point of intersection of these two will be the point where the image is going to be formed. The point where the rays after reflection from the mirror meet at or appear to meet gives the image of that point of the object. You'll always find that the image which is going to be formed will be of two kinds. Either it will be a real image or it is a virtual image. Real image is the one where the rays of light are going to actually meet each other. पर अगर वो meet नहीं कर रहे, पर वो जैसे in case of this one, they are not actually meeting, but it seems that they are meeting behind the mirror this way. Then it is a virtual focus. This is the real focus. This is the virtual focus. So if the reflected rays actually meet at a point, the image is real. But if the reflected ray appears to meet at a point when produced backwards, the image is virtual. A real image can be obtained on a screen, but a virtual image cannot be taken on a screen. A real image is inverted, but the virtual image is erect. So this gives us a very important differentiation between real image and virtual image. The 3 points are: a real image is formed when the reflected rays actually meet each other at a point. Virtual image is formed when the reflected rays meet on producing them backwards. Second point, real image is always inverted, ulta dikhega, whereas virtual image is always erect or upright. Third thing, real image can be taken on a screen, whereas virtual image cannot be taken on a screen. So this is the differentiation between real image and virtual image. I stop here for this video and we'll start the drawing of the ray diagrams in our next video.